Lesson 2, page 242, number 25. The initial angular velocity is 20 radians per second. The change in angular displacement is 15.29 revolutions. We know we want to make those jive, so I'm going to multiply this by 1 revolution over 2 pi radians. So that bike tire is going through almost 16 revolutions, and that's equivalent to how many radians does that work out to be? 100. 100?
Yeah.
Okay, and since we know the bicycle is coming to a stop, well, when it comes to a stop, the wheels aren't going to be spinning anymore. So the final angular velocity is going to be 0 radians per second. And the next thing we want to get is that time right there. So you can find the average. So one way of doing it is you can find the average angular velocity. So on average, initially it was going 20 radians per second, plus in the end it was going 0. You add them up, divide by 2, and you end up getting 20 radians per second plus 0 radians per second all over 2, and the average here is 10. So that's how fast the tire is spinning on average. Sometimes faster, sometimes slower, but on average 10 radians per second. And now that we know that, what can we do to get the time? To what? Average omega equals
Change in
theta over time. So we know the average angular velocity was 10 radians per second, and it went through an angle change of 100 radians. And we're trying to figure out how much time, and that time turns out to be 10 seconds.
Yeah.
Yes.
What?
Oh wait.
I guess that makes sense.
They're very simple.
Can you leave it in
Right?
revolution?
I mean, it makes sense.
You cannot leave it in revolutions unless you change your angular velocity into revolutions.
How would you do that?
It's the opposite of what we did before.
You'd have to
1 over 2 pi radians would be, and then you would multiply by the, right?
yeah, 1 revolution over 2 pi radians.
That's right.
And then what about that the angular acceleration? The angular acceleration is equal to the change in the angular velocity per time. So that's going to be equal to, how much did it change? Well, it's always final minus initial. So what's going to be the change?
-20.
-20 radians per second all over a time of 10 seconds. So basically, I'll just go up here. The angular acceleration is going to be -2 radians per second squared.